Hi everyone. This is a video solution for question number 36 from chapter 8. This problem has to do with this car that's traveling west, so I put a negative in front of its 15 meter per second velocity with a mass of 1,050 kilograms. Now a truck is traveling east and it's traveling east at a velocity of 10 meters per second with a mass of 6,320 kilograms. These two vehicles directly collide, so collide perfectly, and part A wants to know, so what's the velocity of the two vehicles just after the collision? So I've already written down our little starter step. My V prime, just to write it out, is the velocity after the collision. But anyway, so what we have is just our conservation of momentum, right? So we have mass times velocity, both things equal mass times velocity. But in the problem, we learned that the car and the truck actually stick together after that collision. So really, we don't even need a plus here. What we need is we need to combine this, which really, it's just rearranging the equation. But we get V prime times MC plus MT, right? So that's going to be the combined mass. Since they're both stuck together, we'll treat them as one object going this velocity. And then this is our, momentum of the car plus the momentum of the truck. So now what it wants to know is V prime, right? It wants to know the velocity after the collision. So we're going to solve for V prime. So we get that by dividing this over. So we get V prime equals M sub C V sub C plus M sub T times V. So momentum of car plus momentum of the truck over their combined mass. Okay, so now what we need to do is plug in the values that we already know. So we know that the mass of the car is 1,050. So we'll just say 1,050. And when I write this out, I keep an eye on the units, but I don't really like to write them because sometimes, like, my fives look like S's, so sometimes when I see seconds, I confuse it for a 5. So, I mean, I know it's probably more proper to put all the units, but I just keep track of them, and when I look at my like after I've filled in all the variables with their values, I kind of do a mental check to make sure that it all cancels the way it should. So that's why I do it this way. But anyway, I'm actually going to rewrite this down here. I'm going to have more space. So V prime equals 1,050 times the velocity of the car, which is negative 15. I did negative, I can't remember if I said it or not. I did negative because it's traveling west. And so since west, is to the left, I always have the left be negative. Anyway, so I'll add the mass of the truck, which is 66,320, times its velocity, which is 10, and that's to the east, so it'll be positive. All over the combined mass, which is going to be 1,050 plus 6,320. And then we just plug that into our calculator. I've already done that, so we end up that V prime, or the velocity after the collision, is equal to 6.43 meters per second. That's part A. And we also know from this the direction, right? Because heading west was negative and heading east was positive. So we know that it's 6.43 meters per second in the east direction. So I'll even write that. Which makes sense because really there's not that much difference between their velocities, but the mass difference is huge. So when you compare the momentums, the truck is obviously going to have much more momentum that's going to, push the car and keep going in its original direction. So that makes sense, which is good. So part B wants to know, it says, what speed should the truck have been moving so that both it and the car are stopped in the collision? So instead of going almost 6.5 meters per second east afterwards, what would the velocity need to be to just stop? Because you can't really change the mass of a truck, at least not easily. So the only thing we could really change is the velocity. So what velocity does that need to be? So the way we'll do this is to look at the momentums. So we'll say, because if they're gonna stop, they need to have equal momentum, right? And then it'll cancel it out and they'll stop. So that'll be mcvc plus mtvt. So momentum of the car, that shouldn't be a plus, it should be an equals. The momentum of the truck. And what we're looking for is the speed of the truck. So this is what we're looking for. So now we just need to, solve it out. So Vt is going to equal mcvc over mass of the truck. So when we plug this in, we end up getting, 1050 times negative 15 over 6,320. Now, this is good because these masses will cancel and we'll end up with, or the units at least, will cancel, we'll end up with meters per second velocity. That's good. When we put that in the calculator, we end up getting 2.49 meters per second is how fast it's going to need to go. So I'll write that up here to get more room for the next part. So Vt equals and remember, that's if that would be to make them just totally stop after colliding. So that's it for part B. Part C wants to know, it says, find the change in kinetic energy of the system of two vehicles for the situations of part A and part B. For which situation is the change in kinetic energy greater in magnitude? So we're going to have to do this part basically twice. So we'll start with part A. This is where I wish I had a bigger whiteboard, because it'd be nice to still have all the information we had from part A. But we don't, so we'll just do our best. So the change in kinetic energy we know is delta K, and that equals Kf minus Ki, right? Well, we know that Ki equals, it's going to be the sum of both the parts, right? So it's going to be 1/2 mcvc squared plus 1/2 mtvt squared. So that's our initial kinetic energy. Our final kinetic energy is going to equal, now remember, this is when they're combining together, so we only have one mass in the combined. So it's going to be 1/2 times m, which is going to be the combined mass. So mc plus mv. I want to say v, that's not right, mt, times that v prime squared. Remember, the v prime from part A was the velocity after the collision. So now we have both of these from our, what the real meaning of delta k is the difference. And so we subtract ki from kf. So we end up getting, and really we could just plug it in and make it a little easier. But I guess I'll write it out. So delta k equals 1/2 mc plus mt v prime squared minus all of 1/2 mcv c squared plus 1/2 mtvt squared. So that's a lot. But luckily we only have, 5 variables, I think, to deal with. And so we just plug all that in and we end up getting that delta k is equal to, and it just wants the magnitude. So if it's negative, I'll just automatically make it positive, right? Because it's just the magnitude. So we end up with 281769 joules of energy, which is a lot of energy. But of course we can, turn that into kilojoules. That'll make it a little easier to use. 1, 2, 3. So that would be 281 point, we'll just say 8 kilojoules. So that's the changing kinetic energy from part A. So I'll just actually write it up here just to get it out of the way. So delta K equals 281.8. And that's kilojoules. So that's it for part A. Now we need to do part B. So this is if the truck was going the velocity to where instead of having final movement, final velocity, then just stop. So that's going to mean that the K, so, same formula here, part B. So Ki is going to equal 1/2 mtvt squared plus 1/2 mc vc squared. I don't really know why I put those parentheses. Okay, our standard thing. And then the kf is just equal to 0, because if they both collide and really truly stop, there's no kinetic energy, right? It's just stopped. So our difference in kinetic energy is just going to be, just 0 minus Ki. So when we do that, we end up getting, so delta K equals 0 minus 1/2 mtvt squared plus 1/2 mcvc squared. When we plug that in, what we end up with is it's going to be negative, but like I said, we're just looking for the magnitude, so the negative doesn't matter, so I'll just make it positive for a magnitude. So delta K is going to equal 137717.3 joules. Once again, put into kilojoules, make it easier to use. 1, 2, 3. Get delta K equals 137.7 kilojoules. So anyway, so part C really wanted to know which change is more, and by a long shot, it's going to be part A, which makes sense, right? The change in kinetic energy, because in part B, the truck is only going 2.5 meters per second, and so that change isn't going to be much at all in kinetic energy. When if it's in part A where it's going way faster, 4 times faster, of course the change in kinetic energy is going to be a lot more. So that makes sense, which is good because that means that we did it right, or at least it's a hint that we could have done it right. So anyway, that's all it wants from us for this question, but I hope you learned something. I hope you were able to see how we can use all of this, and I'll see you in the next video.